The idea of our ever-changing position in space is inherently linked to the concept of relativity. In simplest terms, relativity is the idea that the measurements of space and time are independent of the relative motion of the observer. This means that our perception of space and time is not absolute, but rather is influenced by our position and motion in the universe.
And Einstein elevated that to a principle and said, if you're not accelerating, you're just moving at a constant speed in a plane, or now, I mean, that's essentially what we're doing now. We're moving around the sun at effectively constant speed. Then you can't tell. So there's no experiment you can do. We could look at the decay of a radioactive nucleus or some electricity and magnetism or bounce a ball, have a pendulum, whatever it is. And there's no experiment you can do to tell you whether you're moving or not. Therefore, that concept has no meaning because you can't measure it. That's led Einstein to relativity. That's the basis, general relativity, which is our best theory of the universe.
Newton's laws stated that two frames of reference moving at a constant velocity relative to each other observe the same physical behaviour. Essentially, there is no absolute rest frame or absolute constant velocity. Everything is relative, and either frame can be chosen as a reference benchmark. As the laws of electricity and magnetism emerged in the 19th century, it appears that these forces could distinguish whether a frame was in motion or not. However, experiments failed to confirm this. Albert Einstein stepped in with his groundbreaking principle of relativity in 1905, asserting that absolute motion at a constant velocity was undetectable by any physical processes. Einstein suggested that the laws of electricity and magnetism were correct, and it was Newton's laws that needed modification.